So here we have a question which really tests your knowledge of vectors, whether you understand what a vector is and whether you know how to work with them. If you don't know those things, then this kind of question is going to be a real puzzle to you. If you do, then it's going to be very straightforward, quite simple. Okay, so let's have a look at the examiner's remarks. And they say that only a minority gave the correct answer in part A. So most people couldn't do it. And in part B, well, this was the least attempted question on the whole exam paper, although there were many correct answers for those who attempted it. The common error was to use S minus T with their answer to part A instead of using minus S plus T. Okay, well, we'll see how that might have happened in just one moment. Let's first of all have a look at the question. So we've got some information up here which includes two vectors given in the two types of notation that are common in this kind of question. So we've got Wx or W2x, and that's given the symbol S, but it's a bold S, so that's also a vector. So W to x equals the vector S, and W to Z equals the vector T. We're also told that Zy to Wx equals 3 to 2. So what this means, obviously, is that Zy here, compared to Wx here, they are in the ratio 3 to 2. So this is 3 to 2 in proportion. And that enables us to answer question A, in fact. So as long as you understand ratio and proportion, you should be able to have a stab at this. So Z to Y is bigger than W to X. How much bigger? Well, it's a 3 to 2 proportion, so the fraction, that's right, Z to Y, the fraction Z to Y must equal 3 halves, in fact, 3 halves of the length, or in this case, the vector W to X. And we need to just draw the vector on here. Okay, so Z to Y is a length, but it's also a vector now. Okay, Z to Y equals 3 halves of W to X. Therefore, Z to Y must equal 3 halves S. And for 1 mark, that completes the first part, part A. So for part B, which is worth 2 marks, we have to work out vector xy in terms of S and T. So let's have a look at that. So xy is this length along here. So again, we need to just draw a vector on. And we need to give our answer in its simplest form. So how are we going to do that? Well, we can't go in this direction because that's what we're trying to find. So the only way is to go around these 3 sides here. So 1, 2, 3. So we're going to go in this direction. So if we write x to y, okay, equals, well, we've got x to w, because we're going around here, here, here. So x to w, which at the moment is undefined. So we'll come to that in a moment. Then we're going to add, so we're adding our vectors, W to Z. And finally, we're going to add Z to Y, which we just solved. Like that. So what we've got to do is sort out this X to W. What we have here is W to X, which is defined up here. So X to W is in the opposite direction. So if W to X equals S, then to get it to go into the opposite direction, we need a scalar of -1. So minus X to W must equal minus S. Okay, so that's just added to that information box up there. So going back to here, we've now got what we need. We've got X to W as negative X, negative S. So negative S. We've got W to Z up here, which is T. So plus T. and we just worked out zy, so 3/2 s. Let's just make that line a little clearer. That's looking like a T. Okay, so just put that line above. You can put the line above or below, but as long as you're consistent, that will be fine. So now we've got x to y equals minus s plus t plus 3/2 of s. And now we can just gather up our s's. So if you think of minus s, well, that's going to be minus 2/2 of s. That would be another way of thinking about it, common denominator. Or you can just say, well, 3/2 is 1.5, so 1.5 s minus 1s is going to be just half s. So our answer is x to y, the vector x to y is going to be equal to 3/2 minus s is half s plus our t. And we're done.